Hey everyone, Mr. Fransky here. This video we're going to kind of put everything together that we've been doing using division and factor theorem to factor a polynomial of high degree. So today we're going to be able to factor a polynomial with real coefficients. Let's take a look. So polynomial, factors, zeros, x-intercepts, stuff that we've been talking about. So we'll start with what is the remainder when 2x cubed minus 9x squared plus 14x minus 6 is divided by x plus 2. So we could do the whole long division thing, but really all we have to do here, remainder theorem tells us that if you do this division, if this is f of x, the answer is going to be f of negative 2. So I just plug negative 2 in, and we can do that in a quick way by doing synthetic substitution. So negative 2 into 2, negative 9, 14, 6, negative 6. Anything missing? 3, 2, 1, 0. Nope, so we don't need any zeros. 2 comes down, times negative 2 is negative 4. Add these, gives me negative 13. Times negative 2 is a positive 26. Plus 14 is 40. Times negative 2 is negative 80. Gives me a remainder of negative 86. So, that's it. Negative 86. Alright. Is x plus 6 a factor of this mess? So to know that, all we have to do is think, well, if it is, so if yes, then I would have, let's call this f of x. I would have f of x is equal to x plus 6 times something and no remainder, so plus 0, right? Because if it's a factor, there's no remainder. The remainder would be 0 because we could just write it as two factors, right? So if that's true, then f of negative 6 would be equal to 0. So the question is f of negative 6 equal to 0, or is the remainder 0? So what I'm going to do is I'm just going to throw negative 6 into some synthetic substitution, and we'll see what happens. So we need coefficients 3, 16, negative 15, negative 16, and 12. 3 comes down, negative 18, negative 2 times negative 6 is 12. Negative 3 times negative 6 is positive 18. Minus 16 is 2 times negative 6 is negative 12. Yeah, gives me a remainder of 0, so yes. Because f of negative 6 equals 0. That's an if and only if. That works only if x plus 6 is a factor. Cool. Alright. If 2, negative 3, and 4 are the roots of a cubic polynomial, that's an x cubed, what could the polynomial be? Well, if those are the roots, how about x minus 2, x plus 3, x minus 4, right? Because if 2 is a root, x minus 2 is a factor. If negative 3 is a root, x plus 3 is a factor. These are if and only ifs from the factor theorem. So if you multiplied this out, we would get x cubed plus a whole bunch of stuff, and then I guess my last term would be negative 6 times negative 4 is plus 24. So now I say, what if we want a leading coefficient of 2? Because right now it's 1. Well, if you want a leading coefficient of 2, just put a 2 in front, right? What if you want a leading coefficient of 5? 5 times x minus 2 times x plus 3 times x minus 4. If you have a specific leading coefficient you want, just put it in the front. This is kind of interesting because a cubic, so a cubic could look something like this. Let's say here we have 2, negative 3, and 4 are roots. So initially, the way I wrote it, it would have end behavior like this. If you make the first thing negative, it just flips the function over. Right? Same roots, but just flips it over. So if you want a leading coefficient of negative 1047, just like this. Cool. Alright, let's try another one. So we're going to divide this using synthetic division. We want to actually get the result this time, I think. So we plug negative 1 into our box, because the opposite, which is what would make that 0. So 3, 4, 5, ooh. There's a missing x squared, right? So we need a 0. Very important when you're doing synthetic division. Negative 6 and negative 1. 3, negative 3, 1, negative 1, 4, negative 4. Add that. Negative 4 times negative 1 is 4. Gives me a negative 2. Times negative 1 is positive 2 minus 1 is 1. So the answer to this, remember these are the coefficients of our quotient. 3x to the 4th. Makes sense. Doing x to the 5th divided by x should be to the 4th power, so 4, 3, 2, 1, 0. So plus 1x cubed plus 4x squared minus 4x minus 2. and then plus a remainder of 1, still trying to be divided by x plus 1. Factored form, let's call this q of x for the quotient. So factored form would be q of x times x plus 1 plus 1. Nice. Okay, so this one kind of takes all of the pieces that we've been talking about and puts them all together. So what we're given here is that x equals 1 and x equals negative 1 are x-intercepts, and we want to completely factor this function. So if x equals 1 and x equals negative 1 are x-intercepts, let's make a list of our x-intercepts and the factors that go along with them. So x-intercepts right now I know 1 and negative 1. The factor that goes with 1 is x minus 1, because if we plug 1 in there it makes 0. And that goes with negative 1 is x plus 1. So we've got two factors right now. So I know f of x, they tell me that they are x-intercepts. They must be factors over here. That's factor theorem. X minus 1, x plus 1. Now it's a quartic, right? Fourth degree. So I'm going to have two more factors that I don't know yet. The goal is to find out what those are, because I want me to completely factor it. So if you have something like, if you know, I don't know, 36 is equal to 9 times something, you don't know what that something is, how do you find it? Well, you divide, right? You would divide both sides by 9, and that would tell you that something is 4. Same thing here. What I'm going to do is I'm going to take f of x, I'm going to divide by x minus 1 and x plus 1, and I'm going to get what those last two things are. So you have two options here. One is you can think about them as one unit. You can think about them as x squared minus 1. And then we can do long division on x squared minus 1. The other option is to synthetically divide one at a time, right? I could do 36 divided by 3 and then divide by 3 again if I wanted to do that up here, right? Same thing here. So let's do the long division first. Let's do x squared minus 1 into f of x, which is 3x to the fourth plus 16x cubed minus 15x minus 16x plus 12. X squared into 3x to the fourth, we need 3x squared for that. I just forget a square, there it is. So 3x squared for that. Multiply down 3x to the fourth minus 3x squared, leaving it lined up so it's nice and neat. Subtract this off. Those go away. 16x cubed. Negative 15 minus negative 3 is negative 15 plus 3. It's negative 12x squared minus 16x plus 12. Come along for the ride. So x squared into 16x cubed, that is a 16x. We have plus 16x here. Multiply 16x by x squared gives us 16x cubed, and then minus 16x, that's right here. Subtract that off. These cancel. Negative 16x minus a negative 16x, those cancel as well. So that's with negative 12x squared plus 12. Negative 1 to negative 12x squared is a positive 12. Multiply, x squared into 12x squared is a negative 12. That's what I should have done. Multiply down gives me a negative 12x squared, and then plus 12. Those cancel out and go to 0. So they asked me to completely factor. So what I've got right now is I know f of x is equal to x squared minus 1 times our quotient here, 3x squared plus 16x minus 12. And good thing our remainder was 0, because it should have been, because they told us they were x-intercepts. So now I have to factor this last part. So this is x plus 1, x minus 1. And then we have, let's see, 3x and x. Let's see, 12 could be 4 and 3. I don't think that's going to work out. It could be 6 and 2. That'll work, right? 6 and 2, 18 and 2. I can make a 16 out of that. Looks like positive 16, positive 18, and then a negative 6. So there we are. We're completely factored. Now, I told you there's another way you can do this if you do it with synthetic division. So I'm going to go ahead and erase this. If you need to come back, you can check it out later. But synthetic division will get us back to the exact same place where long division got us. It just does it a little bit faster, I think. So with synthetic, what I'm going to do is I'm going to divide by these things one at a time. So, let me just erase my thing. That's okay. So, I'm going to divide by these one at a time. What's going on is, like, if I divide by this 3 and then 3 again, you would get 12 and then 4. It works the same way. So I'm going to use negative 1. So I'm going to plug positive 1 into the box, and my coefficients are 3, 16, negative 15, negative 16, and 12. Okay, so 3 comes down, times 1 is 3, 13, 13, negative 2, negative 2, negative 18. Uh-oh, I did something wrong. Is that a 16? That's a 16. So that makes this a 19. Which makes this a 19. Makes this a 4. Which makes this a 4. Which makes this a negative 12. Much better. Negative 12 and 0. Okay, so at this point what I have is I just divided by the x minus 1. So right now, I know that I have the x plus 1, and then the two things are still left. And that's equal to 3x squared, 3x cubed, excuse me, plus 19x squared plus 4x minus 12. So I'm going to use these as my next coefficients. So to explain that a little bit better. What I just did was I divided both sides here by x minus 1. So f of x over x minus 1, which we know is x plus 1 times question mark times question mark. We know that's equal to our quotient down here. 3x to the third plus 19x squared plus 4x minus 12. So now what I'm going to do is divide that by the x plus 1. So I just throw negative 1 in, and I already have the coefficients listed here, so I'm just going to use them. 3 comes down, negative 3, 16, negative 16, negative 12, positive 12, and 0. Good. So once again, I get the 3x squared plus 16 minus 12, which is exactly what we have here. So we have at this point f of x is x squared minus 1 times, x squared minus 1. Bottom of the screen here gets kind of off with the calibration. What am I doing? F of x at this point is x squared minus 1 times 3x squared plus 16x minus 12. And then we solve it the exact same way we did up here, right? Either way you do it, you get the same answers. Kind of cool. All right, that's all I've got for you. Love you guys. That's why I'm here. Have a great day.